Now that our delta time system and difficulty ramp are in place, this is the perfect lesson to introduce a pressure system, something that will create a sense of urgency into the player. This will be reactor instability. Right now, we only have 3 reactor cells that are on our battlefield. What we'll do is we'll use delta time and our ramp to spawn new cells on the battlefield. We'll also make sure that those cells are not stable. We'll make them unstable so that after a certain amount of time, they'll blow up and create radioactive meltdown, lowering our containment. So let's head over to the computer screen and let's dive right in. So I have lesson 6 here, our starter file, open in vscode.dev. I'm going to minimize this here for 1 second though and open that file directly. So we're going to open up the Corefall folder, lesson 6, and here is that starter file. So let's see what this looks like. Okay, so all of my cells, my 3 starter cells are gone. Nothing is spawning, so that's kind of a bummer. Although it looks like the ramp is working, so that's good. I mean, the ramp is working, but no cells are spawning yet. So we definitely want to fix that. So broken game, no surprise there. It's going to start broken, and we have to fix it. So let's head to our mission checklist to figure out how we are going to do that. We'll start by looking at mission number 1. We're going to add the cell pressure system constants. So this new pressure system is all based on cells. We're going to define some constants that we can use, some parameters that we can use to tweak how this system works. So I'm going to search for that tag, mission number 1. And right here, this is in our student edit zone. So these are the places, these are the variables that we can edit to change how the game plays and feels. So let's look right here. We have cell timer max seconds and max number of cells. So that is those are our cell pressure systems. So our cell timer, remember we said that our cells are going to start stable, and after a certain amount of time they're going to become unstable, they'll explode and put radioactive waste all over the battlefield. Well, those timers, it looks like right here we're starting at 120 seconds. That's 2 whole minutes. If you remember, our difficulty ramp, what is our difficulty ramp? It's like, I think our difficulty ramp is like 75 seconds. So after 75 seconds, we'll hit maximum difficulty. That's no good. I mean, this is going to be 120 seconds. So we got to change this. Let's lower it down. I'm going to give myself, I don't know, I'll say every cell will have 8 seconds to detonate. All right, that's what I'll pick. And then the maximum number of cells that we'll have on the screen at any time, I don't want it to be 1. I'm going to set it to 6, so it won't get too out of control. If there's more than 6 cells, we won't spawn anymore until one of them blows up, and then we'll spawn another one. So I think those are going to be some nice cell pressure constants for me. But if you wanted to make it more hectic, you could set this to be like, I don't know, 15. Now your game's going to be crazy to play. And if you want your cells exploding all the time, set this to like, 4 seconds. But for me, these gameplay values are great. Mission 1 in the books. On to mission number 2. We have to generate our cell timer data. So it looks like we are in generate cell data. So remember when we talked about creating the cells, we had 3 sort of functions here. We had to generate cell data, then we spawned the cells, and then we updated the cells. Okay. So in generate cell data, this is where we're creating the data object. We had randomly created an X property and a Y property. So we randomly positioned the cell horizontally and vertically. But now it says we need one more property. And the property that we are going to need is we got to keep track of the timer, like, right? Because we just set, didn't we just set a variable called, like, what was it, max cell timer? It was like 8 seconds. And so that 8 seconds, we got to keep track of that. And then we're going to decrease the timer amount. So it'll be like 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1, then 0. And when that property is at 0, it's time to explode the cell. So we're going to create a couple more properties. I'm going to create timer seconds, and I'm going to set it equal to that constant that we just looked at, cell timer max seconds. So that's going to be like 8 seconds. And then I'm also going to create max timer seconds, and I'll set it to cell timer max seconds. Yeah, that works for me. Oh, get rid of the semicolon. I'm sorry, folks. That should be a comma, not a semicolon. And so I'm going to keep track of both of these. And the reason why is when we create the cell, I'm going to look at ratios of these. So it'll be like 8 over 8. and then it'll be 7 over 8, and then it'll be 6 over 8, and then 5 over 8, etc., all the way until it's like 0 over 8. And so we're going to use that ratio, which is decreasing in value, to help us like almost animate the cell when we draw it. And we'll look at how those ratios are going to be important to us. This will never change. It's always going to be at 8, but this will constantly change as we update our cells. All right, so now we have the timing mechanism in place for our cell. We are beginning to make them unstable, which is going to be super fun. Mission number 2 in the books. Let's head to mission number 3. It says the cell limit. We're going to limit the number of active cells. Let's prevent the system from exceeding the maximum cell count. Well, if I run this right now, I don't even know. Am I spawning any cells yet? Hello? 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 No cells are being spawned. Super, super lame. Well, if we look here, it's just saying spawn cell. So this is our spawn cell function. So anytime we call spawn cell, remember we were calling this originally, we spawned 3 cells. Now we're asking a question. It says if false, return. Okay, if false. Well, false is never gonna be true here. So this is a problem. We got to ask a question here. We got to ask a question. What question do we want to ask? Well, we want to prevent the system from exceeding the maximum number of cells. Okay, so we have that variable that we just created. It was called max cell count. We're going to check it, or it was called max cells. So remember, we have this array called cells, and we're going to get its length. Length. I got to spell it out. If its length is greater than or equal to that variable that we created called max cells, which is 6. So if the length of the array is at 6 or more, then we're going to do this. We're going to return. And return just means get out of this function. We're going to get out of this function. We're not going to give anything back, and we're just going to end it. And then this line will never get called. However, if this question is no, we won't return. And instead, we will do this. We'll push our data into our cells array. So we're going to actually generate our cell. But right now, I mean, this is kind of upsetting. I'm not seeing any cells here. We updated our pressure system constants. We added some new properties to our cells for timers, and we have set the cell limit, but I don't see anything. So I'm really, really hoping mission number 4 is going to fix this for us. And I think it is, because mission number 4 brings us to the update cells function. And if you notice, update cells is based on DT. We've got to use DT here. Look at the first thing we do. We have this variable called cell spawn timer seconds, and we are subtracting DT from it. What in the world is cell spawn timer seconds? Let's hit Control F when we highlight it to bring it right up in here, and let's look at where we find this. So if I scroll up, we declare it in our gameplay variables right here as 0. And then we reset it, reset game to defaults right here. Okay, it's set to cell spawn interval seconds. And if you remember, I believe we use this cell spawn timer seconds is equal to cell spawn interval seconds. And cell spawn interval seconds is the thing that we are controlling with our ramp. Excellent. So remember, this is going to be changing. As we play the game more and more and more, it is going to decrease from, where is it? It's going to decrease from 2.5 seconds, so spawning every 2.5 seconds, to spawning every 0.6 seconds. So we're going to use this to update our spawn timer. So right here, we decrease our spawn timer by our time interval. And if that spawn timer is hit 0, so maybe the spawn timer was 2.5 seconds at the beginning of the game. We subtract our time interval, and when it hits 0, we want to spawn a cell. And then later on, cell spawn timer might only be like, 1.2 seconds. So now we have to subtract less time before it hits 0. And then at the end of the game, it'll be 0.6 seconds. So we subtract even less time before we spawn a cell. Right here is where the magic is going to happen. We are going to spawn a cell. So we'll call spawn cell. All right, let's check this out. Let's run this. Let's see this battlefield get ridden with cells. Every 2.5 seconds, it should spawn. Whoa, my goodness gracious. What in the world just happened? That's not what we want. That was like very bad behavior. They shot all at once. And now if you look, 1, 2, 3, 4, 5, 6, we hit our maximum cell count. So I don't know, if I start scoring a cell, they just automatically keep popping up. Notice they're not going, nothing's happening more than 6. Hey, let's test something. Let's be fun here. Let's just go up for a second. Let's just get rid of, I'm just going to change what we did in mission 3. I'm going to put it back to false really quick. So now we're always going to generate cells. I might crash my game. Let's just see what happens. At 2.5 seconds. Oh my goodness, there's so many cells. This is not going to be good. I have to fix this. That's going to crash the game. So let's put that back. Let's put that back. We got to have that check for the maximum number of cells in place. But the problem is, see, we're setting the cell spawn timer. We're decreasing it, and if it's less than 0, we're spawning a cell. Well, the next time we run this, it's still less than 0 because we just keep subtracting from it. If it was at 0, we subtracted. Maybe it's like negative 0.033, and then negative 0.066, and then negative 0.099. Every single frame, we're going to then continue to spawn cells. What we need to do is reset the spawn timer. That's a huge important thing. So we're going to take that variable, cell spawn timer seconds, and we're going to reset it. Now we're going to reset it to whatever the current value of cell spawn timer seconds is. And if you remember, this is the thing that we are setting with our ramp. So when we start the game, it's at 2.5. And then as the game progresses, maybe it's at 2.2. And then as the game progresses, it's at 1.8, and then 1.3, and 1.1, and then 0.9, and then 0.7. And after 75 seconds of playing the game, our cell spawn timer is at its max difficulty of 0.6 seconds. All right, now if we run this, let's just click off of here, make sure that saves. If we run this now, we should only create one individual cell. What? That's not correct. Let me try clicking off of this again and refresh the page. Let's try that one more time. What? Something funny's happening. I'm going to pause the program. Well, I found what was funny. What the funny thing that was happening is I said cell spawn timer seconds, which is our variable that we're decreasing to figure out when we spawn our cells once it hits 0. I set it equal to itself. Oh my goodness gracious. How silly am I? This should be cell spawn interval seconds. There we go. That's the thing that we are controlling via the ramp. Let's just verify that if I go to update ramp values right here, cell spawn interval seconds is what we are used to control the ramp. So now when we run this, let's refresh the game. We should, I swear, we are going to get one cell spawning, one cell, and then another cell, and then another cell. And you can see our spawn rate is increasing, okay? So now our cells should spawn almost like every 2 seconds here. 1, 2, 3, 4, 5. I have 5 cells, unless they spawned on top of each other. I don't think that probably happened. Oh, there we go. So I'm wondering, maybe a cell spawned on top of each other, but now I have 6 cells. Perfect. All right, so they're spawning nicely there. So really happy. All right, so let's look at mission number 5 next. It's right down below here. Mission number 5 says it's a cell countdown. We want to decrease each cell's timer over time and ensure the timers update using delta time. So remember, we set those properties, those cell timers. Right now, for each iteration of our game, when we update our cells, I also want to update the timer of the cells. So we're looping through all of our cells, but look how we're looping through our cells. We're using that backwards looping method. For let I equal cells.length minus 1. I greater than or equal to 0, I minus minus. Why are we doing that? Well, remember, if cells is equal to an array and we have cell 1, cell 2, cell 3, cell 4, these positions in the array are position 0, position 1, position 2, and position 3. The length is 4 elements, but we're doing 4 minus 1, which is 3. That puts us right here at the end of the array. And then we loop backwards. So we're going to start with this cell, then this cell, then this cell, and then this cell. So the first thing that we're going to do is we are going to grab the current cell. So I'm going to say cells, square brackets. I'm going to reach in and grab a cell at a position. I could do 3, I could do 2, I could do 1, I could do 0, or I could do I. And I'm going to target that particular cell's timer seconds property. And what we're going to do is we're going to take that property and subtract dt. So minus equals our time interval. I'm going to get rid of these lines of code here so we don't crash our program. Let's just recall when we defined our cell, we set timer seconds equal to cell timer max seconds. So this was like 8. And then we're going to decrease it. So it'll be like 7.5, then 7, then 6.5, all the way down until it is at 0. Mission number 5, I believe, is complete. So what are we going to do here in mission 6? Well, if mission 6 is all about these cell explosions, because eventually when that timer hits 0, we are going to explode the cell. So what does that mean? When the cell explodes, we want to take some containment damage and get rid of the cell. All right, so the reason why we are looping backwards through the array is because this is what we do when we want to remove an element from the array. So this mission number 6 is where we're going to remove it. So containment, when it explodes, if the particular cell, if their timer seconds is less than or equal to 0, it's boom time. We're going to explode the cell. We don't want to subtract 0 from the containment. We want to subtract off containment damage per explosion. That was a constant we set quite a few videos back. It's equal to 20. But we know that that could cause our containment to go negative. So we're going to constrain that value. So let's constrain it. So containment is equal to constrain. And what do we want to constrain? We want to constrain the containment. Oh, we don't want to constrain the containment. And the lower bound is going to be 0. That's our smallest possible value. And our highest possible value is our constant max containment. All right, so we're going to take damage now when the cells explode. Let's just test this out. I don't know. Will I take damage? Let's just see. 2 seconds, the cells spawn. All right, and now 8 seconds later. So when the time hits about 10 or 11 seconds, we should take damage. This cell's going to explode. Whoa! That was quite the explosion. That was not the desired effect. First off, the cell didn't disappear, and we took damage continually as time advanced on. And the reason why is because we never removed the cell whose timer was at 0. And so that's the last step here. So in the array, cells, that's the container that is holding all of our individual cell objects. I'm going to call .splice. Remember, splice is what we use to remove an object from an array. What object do I want to remove? I have to give the position. Well, our position is right here in this variable I. So we're going to splice I, and then we got to say how many elements we want to remove starting at that position. We want to remove just 1. All right, so mission 6 should now be in place. Let's take a look. So if we look, 2.5 seconds, our cell's going to spawn. Boom, there it is. And 8 seconds later, so at 10.5 seconds, this thing should explode. Get ready. And there it is. It's gone, and we took that containment damage. Awesome. And it looks like this is working nicely, continuously. Although, there's one thing I don't like. I'm just looking at these things. How do I know which one I should go for? Like, which one is about to explode? We need some visual feedback here in our game to tell us the danger level of these unstable cells. Hopefully, we will get to that. Oh, and look at that. I have no game over condition anymore. I got to put my game over condition back somehow. So let's look at mission number 7. Mission number 7 is all about the danger visuals. Hey, look at that. We said we need some way to visually see what cell is about to explode. And so if you remember, we said, at the beginning of this video, we were going to talk about the cell's timer, and we were going to look at ratios of the cell timer. What was it? Cell timer over cell max timer. I'm butchering the variable names, but we said, okay, it's going to be 8/8, and then it'll be 7/8, and then 6/8, and then 5/8, and then 4/8, all the way down to 0/8. We're going to use those values here to help us visually show the danger level. So if we look, we are creating inside of our draw cells function, we got some new stuff here. We're looping through. So we're saying, hey, give me an invisible marker, no stroke, so I don't see the outline. And then for every cell in my array cells, we're not removing anything from the array, so we can just loop directly over it for const cell of cells. We are creating a variable called danger %. And the danger % right now is just hard coded, set to a specific value of 0.25, a 25% danger level. I don't know if that's great, because I think when we run the game, if I refresh the game, when the cell first pops up, it's not that dangerous right now. Okay, now it's a little bit more. It's getting more dangerous, and now it's super dangerous. It is about to explode. Watch out, watch out. There we go. So I want to change the danger level dynamically based off of how much time is left on the cell timer. So what I'm going to do is I'm going to get rid of 0.25. Let's take, and I'm going to put it in parentheses here to start, the given cell that we're working with, so cell, and I'm going to access its timer seconds property. And then I'm going to divide that by cell.max timer seconds. It's max timer, cell timer seconds. So when we start the game and a cell is spawned immediately, this is 8 divided by 8, which is 1. And then this is like, 7 divided by 8, which is, I don't know, not 1, but less than 1. And when it's 4 divided by 8, it is going to be 0.5. And when it's 2 divided by 8, it'll be 0.25. So this number is going to be decreasing, getting smaller and smaller and smaller, until it is eventually 0. But danger percent, like when this is 0, we should be at a maximum danger level. And when this is 1, right? If these things are equal, our danger level is going to be 0. So what I'm going to do is 1 minus that amount to give me the danger percentage. And we're going to use that danger percentage. So this number right here, this is between 0, this is between 1 and 0, okay? That's super special. Danger percent is between 1 and 0, and what we're going to do is we're going to use that decimal number between 1 and 0 to gradually change the cell color. So when it's not dangerous at all, it'll be green, and then it will slowly change to like a red color for us, alerting us that it's dangerous. And the way we're going to slowly change a value based on some numerical value between 0 and 1 is with linear interpolation or lerping. So we are going to lerp again. Awesome. So we used lerp in our last video for our ramp, but this time we are going to lerp a color. So we're going to do lerp color. Now we're going to have to put a starting color, an ending color that we want to go to, and then a value that we are going to lerp over, and we're going to lerp over danger percent. This is going to be our number that goes from 0 to 1. All right? Wonderful, 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 wonderful. All right, so let's see. I'm going to minimize, or not minimize that, put my semicolon. So our starting color. What colors do we have to work with? Let's go up to our color palette. In our color palette, I have cell safe color. Okay, so that looks pretty good. And I have cell danger color. Okay, so I have cell safe color, which is got a lot of green, FF, and then here's cell danger color. It's got a lot of red, FF. I also have this like cell critical flash color. We'll take a look at that in a second. But I'm going to use these two colors, which are hexadecimal strings. Okay, they're hexadecimal strings. But when we come down to here and we're going to lerp, the lerp color function doesn't require a hexadecimal string. It requires a color object. So we can get that color object by calling the color function and passing in the hexadecimal string that we want to use. So I'll do cell, cell safe color, all right? And then our ending value will be a color object, so we'll call the color function. And I'll pass in cell danger color. And we'll move from here, our save color, to here based on our danger percent. Now I'm realizing I said this is between 1 and 0. I should say it's between 0 and 1. That makes more sense. So when danger percent is 0, we're going to be this color, which is green. When danger percent is 1, we're going to be this color, which is red. Anywhere in between, it's going to be a blend of those colors. We're going to linearly interpolate. It's going to be that nice, ramp graph that I showed you in our last video. And then let's look at what's happening here. We don't actually have to write this code. It's here for us. But then it says if danger percent is greater than 0.75. So if this danger percent is greater than 0.75, and we got this interesting little thing here. This is just going to say, don't do it every iteration of this function, every frame of our game. Just do it like every so often. We're going to change our color so it's that critical flash color. It's going to be white. So like every, 10 times in a second, it's going to flash so that it's white. So let's run this. Let's just see if our color change is going to happen. So are we lerping our color? So right there, it's green. It's starting to look yellow. It's starting to look orange and red. And then look at that. It's flashing. Hey, Now I have that visual indication of, oh my God, this cell is dangerous. Oh, I missed it. This cell is dangerous. I should go for this one. Let's get it in. Let's get it. And perfect. I scored it. So that lerping is working really, really cool. This is some really neat code here. Mission number 8. So our last thing, I really hope it's about triggering game over. Oh, thank goodness. It is about triggering game over, because right now, as our cells explode, nothing kills me. I'm dead, but I can still play. All right. We removed our game over condition. So we got to put it back in here for our automatic spawning. So this is in, where does this put us? In update cells. So this is going to happen in update cells. We check our spawn timer. We see if we can spawn it. We update our countdowns. We check to see if they could explode. If they explode, all right, we're going to check to see now, right? So this is if a cell exploded. If a cell exploded, we reduce the containment level. And now we ask another question. If the containment level is now less than or equal to 0, what does that mean for us? It means game over. So we got to trigger the game over state. Remember, we have a variable called current game mode that is keeping track of the current game mode of operation. We're just going to set it to our game mode object's lose property. If that happens, our game will end, our lose overlay will be drawn, and the game is done. Mission number 8 in the books. Let's test this whole system. Is our pressure system active and operational? So I score some goals. Let's see. All right, I score a goal. Right here, let's just look at that nice thing. All right, color lerping looks great. We get that nice flashing here. Our containment's going to go down. If I score a goal, can I get this one in? Right at the buzzer, our containment goes up. Cells are spawning faster. It definitely looks like. So our spawn interval right now is like 1.8 seconds. So that's pretty good. All right. They're spawning faster and faster. So the game is getting more difficult. Let's just see. How's our max cell count looking? I think it's going to look pretty good. And right there, that last cell exploded. My containment's at 0. It is game over. Done. Man, I'm bad at this game. I'm going to get better. I'm going to practice. I promise. If I enter to restart, we wipe over, we're back to our starting position, our ramp resets, our time resets, our cells reset. Everything is playable and operational. I got to tell you, this game is a lot more fun now that we have a working pressure system in place. These reactor cells, they spawn sporadically throughout the game. They're using the difficulty ramp to spawn faster and faster and faster. And now they are unstable, right? We have these timers in place that can decrease, 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 and eventually explode. This adds that element that I think we were missing, that gameplay mechanic that forces us to react and can punish us if we react poorly. This is a great place to stop, and I'll see you in the next video.